Hit that with that. Okay, anyway. All right, okay, power series. Okay, so now, now when we're talking about this now, power series, what do you think that means? Yeah, there's going to be a power, so our power is going to grow exponentially out of this, right? Okay, so basically something like that. So, definition of power series, if x is a variable, so x is throwing a new variable in here, and then we're going to try and figure out what x is going to do to it. So, remember, if it is going to, if certain values are going to go to less than 1, excuse me, sorry. Yeah, certain values go to less than 1, then that piece will converge, right? So, like, kind of like when we had our R-values. Remember that? The R geometric? Yeah. Yeah, okay, so it's less than 1, so therefore it would converge. Now, in this thing right here, it's written slightly different here. Okay, sorry, had to adjust. Okay, there we go. All right, so right here, if you notice, it goes a sub naught because why? K equals 0, right? Okay, so k equals 0, so I start off with that, and then it gives me my first term plus, where k equals 1 is my continuous where it just goes on from there. Okay, so where coefficients a sub naught, a sub 1, a sub 2 are constants is called a power series in x, or power series centered at 0. Okay, centered at 0. Now, the ones that are not centered at 0 is this thing right here, where I have some type of binomial there, like x minus c, where c is a constant, call it power series in x minus c, or power series centered at c. So if you guys remember when we did, we didn't do it in here, but you guys should have had it at some point. When you're actually taking parabolas and moving it, you would remember in vector form, you have the parentheses x minus h squared plus k, right? And so on the inside would move it, right? Left and right. Yeah? Yeah. Okay, good. That's what we're trying to talk about. So we're talking about where it's going to be centered at. So we're going to center it at some number. And we're going to do some problems that you're going to see this. Now, for all values at x, we're going to figure out, is it going to converge or diverge? And at a certain point, we're going to see if it is going to or not. So if x equals 0 in a power series, okay, bam, 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 or if x equals c in a power series here, then the power series equals a sub naught, okay, which is basically like my first term from there. So in words, power series is a sum of a infinite number of monomials. Okay, yeah, right? Doesn't really mean anything yet, right? All right, so now for this one right here, let's see. So this one's going to start off at, for this one is starting out at k equals 0, so that means that this is my first term plus my sum of my terms from here. So let's take a look. I'm going to have insert page after. So I have sum as k equals 0 of infinity, and I'm going to have, what, x to the k. So x to the k over k factorial. X to the k over k factorial. Right here, let's try this with ratio. Let's try a ratio test on this. So in a ratio test, I'm going to do the limit as n goes to infinity of x to the n plus 1, right? Over n plus 1 factorial over x to the n over n factorial. That's going to turn into x to the n times x over n plus 1 times n factorial times, on top I'm going to have n factorial over x to the n. Okay, from here I'm going to do some canceling, right? So cancel out the n factorials, cancel out the x to the n's, and so I'm going to be left with x over, so I'm going to end up with like this. So if I'm doing, let's figure out what this is. And it's going to be the limit as n goes to infinity of 1 over n plus 1. Now, I took out that x value because I'm going to try and figure out what values for that am I going to get something. So, now in this one right here, what is that going to do? As n goes to infinity, I get what? 0. Okay? This goes to 0. So, let's go back to what it said. So now, if it's equal to it's equal to something over here. Ah, dang it, where did it say? Maybe I'm... Yeah, okay, yeah, I haven't got that far yet. Anyway, so this one right here, so this one is going to converge, isn't it? So as my limit goes to infinity, no matter what x is going to be any number, right? So absolute value, any number, positive or negative, it's still going to converge to 0, isn't it? So yes. Okay, so because the ratio test, this one's going to go that it is going to converge. All right, so let me do next one, page blank after. There we go. Okay, so now on this next one here, B. All right, you guys ready? So you guys are going to read this one for me. K, xk. So sum k, x to the k over 4 to the k.
Yeah.
All right, what's k? Start off.
0.
Okay. Now, from this one right here, I'm not going to write my terms for this one. Yes, the pattern, it's great and all that, but this is the meat and potatoes of what I really need to do. So, for right here, what should I try and do for this? What's the easiest test that we've actually figured out so far? The easiest test was the root, but can I do root on this one?
No.
Say no, because I still have that k, right? If the k with just some constant value and not part of this, I could actually kind of do that, the root test. But let's do the ratio test again. So if I do the ratio test again, I'm going to have the limit as n goes to infinity of n plus 1 times x to the n plus 1 over 4 to the n plus 1 all over n x to the n over 4 to the n. Rewrite it, n plus 1 and to x to the n times x to the 1 over 4 to the n times 4, the reciprocal, 4 to the n over n x to the n. And I am trying to go through this kind of quickly. I'm not intentionally trying to go quickly. There's just, I want you guys to have practice on this once we get to this. I'm only going to do 4 examples because I want you guys starting on these today. All right, we could do some canceling, right? So cancel out my 4 to the n's, cancel out my x to the n's, and what am I left with?
N plus 1x.
Okay, so I'm going to have, let's take out that x, right?
Yeah.
Okay, so limit as n goes to infinity of n plus 1 over 4n.
So the absolute of x is just the x factor? Or I mean, like that.
Yeah, the x.
factor.
Because
So the
it's going to be, I'm trying to figure out certain values of this. So now in this case right here, since I have 4n, as I take the limit to infinity, I get what? 4. Okay, so equals 1 over 4. Now, what is going to make this piece right here, greater than 1? Remember, as it goes to infinity, I want it less than 1, right?
X is greater than 4.
Okay, when x is greater than 4. So I'm going to set this up now. I'm going to say that it's going to be like that. So I'm going to go that when x is going to be, for this, it's going to converge from there. So from here, I know that I'm going to have, if it is going to be, because absolute value, when I do this, it's going to have a radius and conversion, right? Radius of convergence. Wow, I don't know why that's so struggle. All right, so the absolute value of this. So now, when I take away the absolute value, what's going to happen? I have two possible answers when I have an absolute value. This is like algebra 1 type stuff. So I'm going to have two answers. It's going to be x is less than 4 and x is greater than -4. And this is where it comes into play, my radius of convergence. So it's going to be between those two things right there. So for my numbers, it's going to, so let's do a little number line here, -4, +4. So in between here, so it's going to converge in here. So that means outside of this, it's going to diverge. Yes? So it's going to diverge. So let's see what happens when I plug in 4. If I plug in 4, right here, +4, what do we get? I get 1, right? Now, you recall, what is my test? What is my ratio test? What happens when I get 1?
It fails. You can't tell.
You can't tell. You can't tell either way, right?
Yeah.
So it's not like a complete fail. It's not. It doesn't give me any information, right? So for this one, we're going to say that it's going to diverge from here. Same thing's going to happen for -1, right? So for -1, if I get that one, I'll put it in the -4, that one is also going to do the same thing. So that means that is also going to, give me no information. So my radius of convergent, so my R, so capital R is going to equal 4, and it's going to converge. So it's going to converge from any point in here. So any point inside there, it is going to converge. Outside of those, it's always going to diverge. So the term radius of convergence is the point. Yes, no, maybe? Not too bad, right? We're really not doing much with the calculus portion. This is all algebra stuff, right?
Yeah.
So the most that we've done is the limit. Okay, so insert page. All right, crap. Wait, no. Where is there it is. What was that, Michael?
He's like, I'm done.
Okay, he's like, okay, k factorial x to the k. So we have, and that's going to be k equals 0. All right, so let's see what we got here. So what test do you want to do? Yeah, let's do the ratio. I like ratio. So it's going to be, and so limit as n goes to infinity.
Not sure, but why do you change k to n? Is there any reason or just
It's a limit process. It's talking about the number sense of these, because k is actually going to be the numbers that I'm putting in. It's the order of the sequence. So we're turning a sum into the sequence of numbers, where this is the s of n. This is the series of numbers, right? And so it's s of n, so it's a series. So this is the sum of the series. And it's just notation. So yeah, it's a sum of the series. So we have a series, we have the sum of the series, and this one goes with k, but then the sums, or the series right here is in n's. So we're just doing that piece as we're doing the math for this. Okay, this one right here says we're adding them all together. This one right here says this is my series. These are my terms that I have right here. Kinda?
Yes, yes.
Okay, alright. Alright, where was that? Factorial, right? And then it's x to the n plus 1 over, it's going to be n factorial x to the n. Okay, so let's rewrite this. I like rewriting it. So it's going to be n plus 1 times n factorial times x to the n times x to the 1 over n factorial and x to the n. Canceling. Cancel, cancel, cancel. So I'm left with, so the limit, so I have absolute value of x, limit as n goes to infinity of n plus 1. That's all I have left, right? Alright, so now, what values would make this one 0?
Zero.
Just 0, right?
Yeah.
So for this one, it's going to be when x equals 0, it's going to be convergent. And when x not equals 0, it is divergent. We okay? All right, so theorem convergent-divergent of a power series. The power series converges for a number where x sub naught is equal to 0, then it converges absolutely for all numbers x for which the absolute value of x is less than x sub naught. Yes? Okay. So the power series diverges for a number x sub 1, then it diverges for all numbers x for which that x, absolute value x, is greater than x sub 1. Okay, series converges, limit as n goes to infinity equals 0. Does that make sense, or would you want, makes it better when I do some math to go along with it? Yeah, let's do some math to make this applicable. All right, so for a power series, okay, exactly one of the following is true. The series is convergent only if x is equal to c. Now, if x is equal to c, what's going to happen? What would that value be? 0. That would be 0, right? So, okay, that would work. So converge only. Okay. All right, the series converges absolutely for all x, okay? All x, so it always converge for everything. There's a positive number r, so that would be my radius, for which a series converges absolutely for all x, where this one right here, and diverges for, this is outside of that, and the behavior series at this must be determined separately. So we actually we figure out what this is going to be, and see what's going to happen at each point. So on that previous problem where I had -4 and 4, right? You have to plug those pieces in to see if that spot is going to be convergent or divergent. Just that point, okay? So it's like testing the endpoints of some type of limit. Okay, so if I have like, you know, what is the minimum maximum over this interval here, you would have to test the endpoints, right? That's basically what we're doing here. Okay, so for example, this one right here converges to absolutely for absolute value of x is going to be less than 4, and diverges when it's equal to 4. Okay, everything greater than. So radius of convergence is 4, and the interval of convergence on the open interval is from -4 to 4, as shown in the figure 26 that we have right here. So there's my radius of convergence. Crap. Taking too long. Actually, why do I keep looking at it? It's like way off.
Yeah, I was looking at it too. 9:26.
There's also a clock down there.
That was the example.
I don't know. All right. Okay. Find the interval of convergence of a power series. Find the radius of convergence of the interval power. Okay, so let's do this. Okay, what test do you want to use? What test has been very, very good so far? Huh? Let's do the ratio. All right, so do the ratio test. We're going to have, let me see, let's get me limit as n goes to infinity of x to the 2n plus 1 over n plus 1 over x to the 2n over n. So that's going to be x to the 2n times x squared, right?
Yeah.
Because I have a 2 times this n value, I have to distribute that, right?
Yeah.
Okay, over n plus 1 times n over x to the 2n. So now, let's see. As, ooh, look at that. Absolute value, x squared, limit, as n goes to infinity, I get n over n plus 1. Now, as the limit goes to infinity, what do I get? 1. Okay, so that's equal to 1, right? So, think about my values of x. What's that going to be? Anything less than 1. So now I have the absolute value of x squared less than 1, right? So I want it to be less than 1 here. So now from here I'm going to have x is less than 1 and x is greater than negative 1.
So it's going to matter if it's squared?
When you get rid of the absolute value. Okay, when you get rid of the absolute value, it's basically square root of 1. Square root of 1.
What about the negative one?
I know, that one's not going to work, right? Ooh,
So x must be greater than I.
0. Any number that we plug in there is going to be positive though anyway, right? So even if I do plug in negative numbers, it's still going to be positive. All right, so let's see. So going back to my problem right here, All right, so for this one, what is my convergence going to be? It looks like if I have my number line, -1 and 1, right? So we have to test. What am I testing? What am I testing? Don't get testy with me. What am I testing?
The radius of convergence? Or
Okay, I'm testing what? Where? Okay, right here. Where it's equal to that is where I need to test. Where it's equal to, I need to test. So, let's go back. All right, so let me see. If it is -1, I still get 1, right? Okay, so if I take the limit as it goes to 1, is that one converge? What does it have to do to converge? Equals 0. Okay, so at 1, is that, or I'm sorry, -1, is that going to work? No, I still get 1, don't I? So that one's not going to work. So what about +1? I still get 1, right? So it's not equal to 0, so it's not going to converge. Who was that? Sorry.
use your
iPhone users.
iPhone.
Okay, so we're going to say that this one right here, it converges. My radius converges, so big R equals 1.
Yeah.
And the radius of convergence is there, so it's going to go from -1 to 1. Come on. And therefore, it's also going to, from -infinity to -1, right? And union 1 to infinity, it's going to I know you guys are all writing this down frantically, right?
That was like
Yeah.
the Manhattan Project.
You know in the Manhattan Project, they all died, right?
They all died. What do you mean they all died? No, they didn't.
Yeah, from radiation poisoning.
Enrico Fermi lived until like he was 80. And Albert Einstein didn't die. Manhattan Project. And Oppenheimer. The scientists.
Yeah, are we talking about the ones that actually did it the first time? They all died from radiation poisoning. The ones that were actually playing with plutonium? No? Okay. All right. Okay, let's try this next problem. Find the interval convergence of this power series. Okay. Let's see. So what do you want to use for this?
Root.
Yes. We're going to use root. Why are we going to use root?
Because they both have the same exponent.
Very good. They both have an expo to k, right? So I could do that. So that's going to be a root test now. So it's going to be limit as n goes to infinity of let's see, it's going to be x like that. Ah, crap. Should be an n. There we go. So what's going to happen to my... So this is going to turn into what? So as this goes to infinity,
Goes zero. With the absolute value.
yeah. So this one right here, in this case right here, for this, it's going to converge absolutely for all real, isn't it? No matter what values x is, this one's going to converge absolutely. So this one's going to, my big R, my radius of convergence, is going to be infinity. Are we okay?
Yeah.
We're still going, right? All right, good. All right, on this one right here, what's going to happen? What type of problem is this? Very good. It is alternating. All right. So what test do you want to use? Ratio test. It's what's been working, right? Let's try it. So, what am I going to do? Since this is an alternating series, what do I do to that little nasty over here? Yeah, take that piece out, and then I'm going to plug it back in, because I know no matter what, this is going to be alternating up and down, right? Okay, so this is the piece that I'm talking about. So if this is greater than 1, right? If this comes out to be greater than 1, then that alternating series is going to diverge. If this is less than 1, then the alternating series is going to converge, right?
Yeah.
Yes? Okay, good. All right, so limit as n goes to infinity of x minus 2 to the n plus 1 over n plus 1 all over x minus 2 to the...
And
N plus 1 plus 1.
Yeah.
At the bottom.
Oh, you're right. Sorry. Thank you.
It's a remedy.
Plus 2. We'll jump into plus 2, right? So it's going to be... Crap, now I just lost it. Okay, so x minus 2 to the n over n plus 1. All right. Good job, you guys. All right, so write it out. So x minus 2 to the n times x minus 2 over x plus 2 times n plus 1 over x minus 2 to the n. So that's going to go away there. And
The denominator is n plus 2 on the left.
X plus 2.
oh, it should be n plus 2. You're right. Dang it. Man. Good job, you guys. Seriously, you're on top of things. So denominator is n plus 2. There you go. All right. I was like, okay. So, let's see. I'm going to have
Well, what does that change?
limit. No, it changes a lot because otherwise it would be divergent for everything.
Oh, yeah, 'cause it's x. No way.
So, as n goes to infinity of, let's see, I'm going to have x minus 2 times x plus n plus, n plus 1 over n plus 2. All right. So for this one right here, what's going to happen? As n goes to infinity, what's going to happen here?
It gets to 1.
It goes to 1, right? All right, so now let's check that. So for this one right here, insert page after. Absolute value, x, is it plus or minus? 2.
Minus 2.
Minus 2, right? So it's supposed to be convergent at this point, right? So when the values at x would actually make this piece converge for here. So now let's take a look. So I'm going to separate to my two different problems. So I'm going to have x minus 2 is less than 1, and I'm going to have x minus 2 is greater than negative 1. Add 2. So x less than 3 and x greater than 1. So what is my big R here? What's my big R? What's the radius of my conversion? What's the radius?
Between
1 and 3. What's the radius?
1.
1. My radius is 1, right?
Right. Can't be there.
Yeah, it's going to be, radius is both of those, right?
Right.
Because of the absolute value, I'm going to have some on the left and some on the right. So it's the radius of convergence is going to be 1. Now, given that, I need to check my endpoints. So what's going to happen when I have 1? All right, what's going to happen when I have 1? Pay close attention right here. If this is 1, this would be, doesn't that make that negative 1 to the 2k? Yes? Over k plus 1. Since it's a 2 right there, that means all of those exponents are going to be even, right? So that means that it's basically going to be 1 over k. 1 over k is what?
Well,
Is-
high harmonic.
Harmonic, so that one's divergent, right?
Divergent.
Huh. So that one's going to be harmonic. That one is not going to work. Okay? So that one's going to be divergent. So 1 is going to be not equal to. Now let's check the 3. Now if I check the 3, let's check 3. So that's going to give me negative 1 to the k, and that's going to give me a positive 1 to the k over k plus 1. And what's going to happen to this one now? It's alternating, isn't it? Now it's alternating 1 over k, but what's that going to be? If it's alternating harmonic, that one is, that one's convergent. That one's going to converge. Because it's alternating, it's coming down the 1 over k, because if I'm looking, it's 1 over 1, and then 1, that's negative 1, then plus 1 over, no, hold on, 1 over 2, starting at 0, hold on. Starting at 0, one minus okay, keeps getting smaller and smaller, right? And they're alternating in between. So this is, because it's jumping back and forth in between there, it's going smaller and smaller. So this one, because it has bounds that's going in between those two of alternating. This one's alternating harmonic. This one is convergent. So it's convergent so that my interval is going to look like this. It's going to be from parentheses 1, and it's going to be 3 bracket.